Okay, how are you everyone? Our lesson today is about rational number. We already studied it in the school, and this is a revision and a study lesson. You can study it at your home, okay? Rational numbers, actually, to take a small brief about numbers, we already studied a group of numbers before, like 0, 1, 2, 3, and so on. We call it what? Yes, it's whole numbers. Yes. The whole numbers, okay, consists of 0, 1, 2, 3, 4. Then we move to another group of numbers which is have right and left, up and down. So we find another group of numbers which is called integers. The integers consists of 0, 1, 2, 3, and on the opposite side, it consists of negative 1, negative 2, negative 3, and so on. So integers is 0, 1, 2, 3 to the right-hand side, negative 1, negative 2, negative 0, and so on to the left-hand side, okay? Okay, I have now something we didn't mention it before. Is there any numbers we miss on the number line? If I have the number line, like this one, actually we start with 0 in the middle, 1, 2, 3, and so on, negative 1, negative 2, negative 3, and so on. Okay, what is the numbers between 0 and 1? In this array, there exist some numbers. How can I write these numbers? Actually, like what? Like 0.5. That's 0.1, a half. So I have some numbers between 0 and 1. These numbers can be written as a fraction. So I get a new set of numbers which is called set of rational number and denoted with Q, the letter Q, rational numbers. Its numbers can be written in the form A over B, and B does not equal to 0. So any number can be written as a fraction. 1 over 5 is rational number. 3 over 2 is rational number. 100 over 99 is a rational number. So any number can be written as a fraction is a rational number. Okay? Okay. How to represent rational number as decimal point? I can represent the rational number as a decimal number by doing the following. If we take an example, write the following number, 52 over 80, in the decimal form, okay? We will use the long division actually. So long division like this, okay? We put the numerator inside, 52, and the denominator outside, which is 80. Okay, let's start. 52 divided 80 can't be, so the result is 0. Okay, but the point give us 3 zeros and put 0 here. What should we do? Actually, I should find something in the times table of 80 which give us the result of 520. So let's try the times table of 80. 1 times 80 is 80. 2 times 80. You can use the times table of 8. 2 times 8 is 16. And put 0. Yes? 3 times 8, 24. And put 0. 4 times 8, 32, 0. 5 times 8, 40, 0. 400. 6 times 8. Until what? I should do this until I reach 520. Okay, I want to reach to this number. Okay, 6 times 8, 48 and 0. 7 times 8, 56 and 0. Okay, I exceed the number 520. So what should I choose? I will choose a small number which is 6. And the result here will be 6 times 80 equal 480. The next step is what? Make subtraction. 0 minus 0 is 0. 2 minus 5, it's 12 minus, here it becomes 4. It's 12, it's 40. Okay? Okay, now we can put 40 divided, I can't start divided 40 with 80. So I have to put another 0. 400 divided 80, can I find 400 here? Yes, it's here. It's on the 5. So it's equal 5. 5 times 80, 400. Make minus 0, 0, 0. So the result will be what? 0.65. Okay? So I know the way. How can I write a fraction, a rational number in the decimal form? Okay, and this form, this rational number, this decimal number, actually we can call it finite decimal number, because it stopped at 5. It's just 0.65. It stopped. We call it finite decimal number. Okay, so any finite decimal number is a rational number. This is the first rule. Okay, what else can be written in the decimal form? Okay, another example. Five divided 18 over 80. Can I write it in the decimal form? Yes. So we'll start my long division. Numerator inside, denominator outside. Okay. 5 divided 8. Actually, it can't be, so it's 0, and put 0 and start to put zeros for free because of the point. Okay, and we will make the times table of 18 one time until we reach 50. 18, 2 times 18 equal 36. 3 times 18 equal 44, 54. Now we exceed the number 50. Okay, what should we make? We choose 2. So it's equal to 2 times 18 is 36. Make the subtract. So 50 minus 36 is 14. Yes? Yes. Then put 0, free 0 from here, from the point. 140. We must continue the times table until we reach 140 or exceed that. Okay? So 4 times 18 equal 72. 5 times 18 equal 90. 6 times 18 equal 108. 7 times 18 equal 126. Still need more. 8 times 18 equal 144. We exceed the number, okay? So what we should choose? Yes, we'll choose the number 7. Yes, that's right. So the result is 7, okay? And put 126 here. Make subtraction, okay? It becomes 14. Then put 0 again. Okay, 140 divided 8, it's equal 7. 140 divided 8, it's 7, which is equal 126. Make minus. Okay, it will become 14. Let's put 0 again and put the 7. Now 7 is repeated number. We can write it like this. 0.27 and put dash over 7, which is repeated number. So the fraction can be written as a repeated decimal number. So this is called repeated decimal number. So I can write the decimal form, the rational number, as a fraction like this, 1 over 5, and as a finite decimal number like 0.65, and infinite repeating number like this, 0.25. 2, 7. So these three forms represents the rational number. Any other form does not represent the natural. It's not a rational number. Okay? So this is a rational number. Now we know the rational number. We know how to use the rational number. As a free small example to know if we are understand the lesson or not, I'll give you this example. Please explain whether each of the following is rational number or not. I'll give you some numbers and tell me if it's rational or not rational. First one is negative 6.382. Actually, it's finite. It's stopped here. And the finite decimal number is rational number, so it's rational. Yes, it's true. Okay? Okay, what about 1.5398881? And 4 over the 81 is bar. So that means that I repeat 81. So it's 1.5398, 81, 81, 81, 81, 81, and so on. So it's repeated decimal number. It's a rational number, as we said before. Okay, what about the following number? 0.4353498, and so on. There is no repeating. And the infinite number, it's not a rational number. Okay, for now, we know the lesson of today. I hope you enjoyed the lesson. Thank you for being with me. See you next time.